So next we're going to talk about kinematics. And kinematics relates displacements, which I'm going to use the letter U to denote displacements, to deformations. And we already said that we were going to call those little delta. And in order to talk about kinematics, we're going to draw some more pictures. So I'm going to draw another rod here. And again, our rod has some coordinate system, x, some area, and we're going to apply some force to it, set with some N. We're going to see what happens. And I'm going to draw what that deformed configuration looks like. It's going to look something like this. So we still have some force here. Still have some coordinate system. And what I'm going to do is I'm actually going to look at what happens to a little slice of this rod, this material. So we're going to look at that little slice there. And you guessed it, that's going to be at some point x. And in the deformed configuration, this bottom picture here, what we're going to see is two things. One, the whole thing's going to move, it's going to translate, and it's going to stretch. So that might look something like this. So now this is the same slice, just in the deformed configuration. So I'm going to draw these guys down here. So here's our original slice. And I'm going to give it some properties here. So this is at the value x. This over here is the value x plus delta x. So that means that the original length of this guy is going to be delta x. And in the deformed configuration, if I bring that guy down here, that might look something like this. Okay, so now we want to know what some of these quantities are. So from here to there, that's the distance that x has moved, right? So that would be u of x. Now, we started off with a little slice of rod that was delta x long, and we're still going to have that same length down here. But now, so that's delta x, but now in addition to that, we're going to have some deformation delta. So now the overall length of our slice is delta x plus little delta. We can do the same thing up at the top. So this point now, we want to know where that's located in the deformed configuration. We're going to need to know what the displacement is at x plus delta x, because that's the location here. Okay, and what I'm trying to do is I'm trying to draw these two things so that you can see that from this line to this line is one length, and from this line to that line is the same length. So these quantities on top are going to end up equaling these quantities on bottom. And that's going to help us when we start to think about what strain is in this case and what that deformation is, how we compute it. So what we're trying to get back to take a step back here, is what we want to know at the end is what we want to know strain. So we said that strain is one of our fundamental quantities, and we said that it was going to be the deformation divided by the original length. So in our little picture here, we can see our original length, L0, is just going to be delta x. What's our deformation, which is the other piece? Well, we can calculate that, knowing that these two are the same length. So everything up top we know, and that's going to be u of x plus delta x plus delta x. So that's the length of the top. And if we want to know what delta is down at the bottom here, all we need to do is take that length and subtract off the other two pieces. So that's going to be minus u of x. That's an x, sorry. And we're going to subtract another delta x. So you can see that if we take these guys together, that's a plus delta x, that's a minus delta x, and we can cross those guys off. And what we're left with is that the deformation of our little slice is equal to u at x plus delta x minus u at x. And if we want to calculate or determine the strain, we can put that on top. So that's u of x plus delta x minus u of x. And we're going to put all of that over our original length, which we said already was delta x. And you can see where this is going. What we're going to do, we're going to take the limit as delta x approaches 0. And what that's going to end up with here, if we take that limit, as our little slice continues to shrink, we're going to end up with the derivative. So we're going to get the derivative of u with respect to x. So strain is nothing more than a derivative of the displacement. And that's pretty cool. So we're going to put a box around that, and we're going to kind of give it some majesty here. All right.